going to find out the opposite of a particular surface, whereas in cube, if we are talking about just the representation, it's a 3D figure, so both are same, but for this topic we are having different category of question. That let's take an example. Let us consider, let's suppose this duster is a cube, let's suppose, okay, so is having 6 face, like 1, this 2, this one 3, 4, 5 and 6, right? These are boundary lines, 1, 2, 3, 4, 4 from here and 4 for the corners, for the pillars, so total 8 and 12, sorry, and these are the corners, 4 here and 4 here, so total 8 corners are there, right? So this cube, which is a 3D figure and is not hollow from inside, is deep, is dense, right? So you are just coloring it, the outer walls of this this particular cube, maybe using one color, maybe using 2 or more colors. The directions in the question itself is given already, that you are using 2 colors or 3 colors or more than that. It's already given in the question, okay? Then after coloring the outer body, of course we cannot color it from the inside, because from inside it's not hollow, it's dense, right? Then after painting it from the outside, you are just going to divide, you are cutting it and converting it into some small cubes, n number of small cubes, okay, n number of small cubes will be there, right? So the question, student, is when suppose we are converting a original cube into smaller number of cubes, we are having multiple number of questions in our mind. The first thing is, whenever we are solving our one question, that means whenever you are converting one cube, the first point that comes in our mind is how many small number of cubes will be there. Number of cubes after converting into small one. Okay, the second question is, for example, this is the room, you are just cutting it, right, just converting it into small cubes, so definitely we wanted to know the number of cuts required to convert into such number of cubes, right? So the second question is number of cuts required. Fine. Now one student is asking me, what is the difference between the edge and the corner? I can make you understand, student, with the help of this diagram, because right now I am not having any 3D figure. So let's suppose this one, this is a cube, right? This is the cube where you can check out, we are having total 6 surface, which we can understand, this top one and this one bottom, okay, this left and right, and this one, the front one and the back side one. So total we are having 6 surface. If you talk about the corners, these are the corners, like you can check out in the room where you are sitting. So these are 4 corners and of course 4 in the bottom. So total 8 corners are there. Edges indicates, in Hindi I am translating, it was earlier, right? Earlier I told you that edge in Hindi means kinara. That means this one, this boundary line. This is one edge, this is another edge, this is third edge, and this is fourth edge. These are edges, okay? So 4 from here, 4 from bottom, and 4 for pillar. Now you can understand the difference between the surface, the edges and the corners. I know you can understand it, right? It's not that difficult. Now the point, student, was, I was just taking one example. So coming to the point, let's come back. Let's suppose in the room in which we are sitting right now, let's consider this room is a cube, okay, and is not hollow from inside, is dense. Fine. Now you have painted it from the outer body, from the outside, of course we cannot from the internal one, from the interior, right? Now we are dividing it into small number of cubes. So different category of cubes will be there. Number 1, from the inside portion. From the inside portion, if you can check out exactly from the inside one, there can be one cube. We can see that from this space where I am sitting exactly right now, from here if you check out one cube, it is a we can observe the thing that colorless cube will be there from the inside body, right? From here if you check out, this will be a cube which is colorless and have no paint, not even on one side, not even in one surface, right? This is the first question, that number of colorless cubes obtained after converting it into small number of cubes, right? The second one is, for example, this is again a surface, right, which is painted from the outside. So when you are going to cut it, you can imagine a student that we will have one cube which whose one surface is in contact of this wall, right? So because this surface is colored from the outer body and the rest of the part is from inside of that particular cube, so the one which I am getting from this middle portion is that one having one-sided colored cube. Only one surface is colored. So I can say that one surface colored cube, one-sided colored cube. Fine. The next one is, how can you check out in the room? Yes, check out the wall. Check out the edge of the wall. Just check out in the room where you are sitting, the edge of the wall. From there, if you check out, there are two surfaces in contact like this, right? Like this. And this is the edge. If you can imagine, and supposing my hand is like a surface, right? So this something like this is there, right? The left wall, and for this one I am just assuming like this. So this is one edge. From there, if you are checking, we are having that cube in which we are having two-sided colors because two walls are in contact. Okay. Check out for the corner in the room where you are sitting. Check out for the corner in the room you are sitting. In the corner, we are having three surfaces in contact, right? So those three surfaces in contact, so that's why we will have three-sided colored cube. So the number of questions we are going to solve for today's session is not so much. It's a very simple and easy topic, student. You just need to understand only one example. After, if that is clear, everything will be clear and you can solve any question of cube anywhere, right? So the first is total number of small cubes when you are converting one original into small number of cubes. Second is the number of cubes cuts, right? Third is one-sided colored cube. Okay. And the fourth one is two-sided colored cube. And third is three-sided colored cube. And this is fifth and this is sixth, right? Next is colorless. So these are the questions. These are the questions, student, that you need to understand today. For that, let me take one example which will make you understand each and everything. Just listen to me. Just listen to me only, okay? And if the things are clear to you, that all okay. If not, then let me know. So this is one example. Let's read the example first of all. Let us consider a cube of dimension 25 centimeter in which all sides are painted with blue color and then it is divided into a small cube of dimension 5 centimeter. So I have given you one example in which we are having an original cube where the dimension are of 25 centimeter. We are dividing into small number of cubes and that small number of cubes are having the dimension of 5 centimeter. Okay. So just forget about cubes first of all. Just forget about cube. Let's talk about a single straight line. So let's say this is a straight line. Okay. Let's say this is a straight line and let's say I'm saying you just divide this line into two small parts, into two equal small parts. Okay. So the number of cuts required to convert it in two small parts is obviously 1. If one cut is there, you will have two parts, right? So one cut is equal to two parts. Converting it in two parts. Let's suppose I am asking you to convert this line into 3 equal parts. So the number of cuts required is obviously 2, right? So 2 cuts are required to convert it in 3 parts. Okay. Similarly, 3 cuts will be required to convert it in 4 parts. So with the help of this example, we are having one simple point in our mind, that is whenever we are converting a cube into a small number of cubes, or we can say whenever we are converting a straight line into number of parts, the number of cut is always 1 less than the total number of parts. Is that clear to you, right? If the cuts are 9, if the cuts are 9, definitely there will be 10 parts. If the cuts are 10, definitely there will be 11 equal parts. So why I was talking about cuts? Because every time it's not necessary, student, that you will memorize all the formula each and every time, but there can be some basic concept, there can be something in basic which we don't need to memorize, that is already we are having in our mind, and from there we can understand the things in a very simple manner. Okay, so instead of thinking about a cube of dimension 25 centimeter, I just assumed a straight line. So here is the simple example for that one. Okay, this is the conversion of the example I have given you. This is the cube of dimension 25 centimeter. I just have divided the cube into small cubes of dimension 5 centimeter. So Let's explaining it once again. We know that we are having a cube of 25 centimeter. So instead of thinking about a cube of 25 centimeter, I just assumed that I am having a straight line of dimension 25 centimeter. Now I wanted to convert it into small parts of dimension 5 centimeter. So if suppose I am just converting it into 5 centimeter small parts, so obviously there will be 5 parts. If you are dividing 25 into 5, 5 plus 5 is 10, plus 5 15, plus 5 20, plus 5 25, right? So for 5 parts, I just needed to cut it 4 times, 1, 2, 3 and 4, okay? 4 cuts is converting this straight line into 5 equal parts. So I just I was just thinking about a straight line, I was not thinking about this cube. Now why I am thinking, student, the very first question that comes is the total number of cuts, right? I am not assuming about the one-sided color, two-sided and the three-sided colored cube. I am just assuming about a simple point, that is I am having a straight line of dimension 25 centimeter. I needed to convert it into 5 centimeters equal parts. So I thought that how many parts will be there? I will have 5 equal parts. For that I needed 4 cuts, right? Now the point is, we are not having any single line, but we are having a cube. A cube is a 3-dimensional figure having x-axis, having y-axis and also z-axis. That means I am talking about L, B and H, according to its length, according to its width and according to its height, okay? So let's once again coming to the same example of the room where we are sitting. You people will assume. If it is clear to you, then let me know. If it is not, a student, I will explain it once again, okay? So right now this room is a cube, okay, and of 25 centimeter only. We are just converting it into small parts of dimension 5 centimeter. We are having the idea that we needed to cut for a single line, we needed 4 cuts to convert it into 5 equal parts. So what you will do for a cube is, according to its length, you will cut it 4 times, 1, then 2, then 3 and 4. Because we are converting it into cube, so definitely according to its width, we need to cut it once again, like 1, then 2, then 3 and then 4. So what will happen, if you can imagine right now, I have just shown the cutting according to its length and according to its width, okay? Okay, so what you can see that on the top we are having a square in the form of a complete pillar. So right now we needed to cut it according to its height like this. So overall 4 cuts are required in x-axis, 4 cuts are required in y-axis and definitely 4 cuts are required in z-axis. So overall we will have 12 cuts, right student? Now the very first formula is total number of cuts. I will student, but one by one. I will explain each and everything, but one by one. I know that most of the 2-3 students have given me the answer for the example I have taken. But just because of your answer, I will not skip to the next one. I will explain you by my own, one by one, because everybody is not having the idea. It's class for me and I have to consider all the students, right? So right now student, because we can understand that 4 cuts in X, 4 in Y, 4 in Z. So overall it's 12 for the previous example. But right now I'm just writing one value denoting with the help of A. Now what is this A? This A is equal to parts in single axis. Part in single axis. This represents number of parts in single axis. And how can I obtain the value of A? It's very simple. To understand the value of A, it is always dimension of original cube divided into dimension of small cube. Okay, dimension of original cube divided into dimension of small cube. Now this time, because we are having one example where we have taken original cube as the dimension of 25 centimeter and we are just converting it into small cubes of dimension 5 centimeter as shown in the previous slide. Just you can read it from here. Okay, so the value of A will be 5 parts. This is 5 parts. I will keep continuing again and again that this is 5 parts. The value of A is some parts. Okay, this is parts. Never answer it only 5. It's 5 parts. Okay. So the very first question is total number of cuts required. So total number of cuts in single axis is 1 less than the number of parts we are having in that particular axis. So in generalized form, I denoted the parts with the help of this variable, that is A, which whose value is always depending on the dimension given in your question itself, right? So total number of cuts will be, if total A parts are there, the cuts will be 1 less than that for a single axis, because this cube is a 3-dimension figure. So you will write the formula like A minus 1 multiplied by 3. Okay, this is the number of cuts, the first formula. The second formula is total number of cubes. Total number of cubes obtained after converting this original cube into a smaller one. So you know what, a student, because you have taken this example already, we are having one cube of 25 centimeter. We're just dividing into small cubes of 5 centimeter. So can you see in x-axis I am having 1, 2, 3, 4, 5 cube. In y-axis 1, 2, 3, 4, 5 cube. In z 1, 2, 3, 4, 5 cube. So it is 5 in x, 5 in y-axis, 5 in z-axis. And generalize, for this example, our answer will be 5 into 5 into 5, that is equal to 125 small cube. But for generalized way, you know that for x-axis you will have A parts, for y-axis again you will have A parts, for z-axis again you will have A parts. So overall I can denote it with the help of this formula, that is A to the power 3. So these are the two basic things. Now coming to the most important point, the third point is one-sided colored cubes. The total number of one-sided colored cubes. So I just wanted to know one answer from your side, student. For there is one question from my side for you people. Can you please tell me one thing? Can you please tell me one thing? That is, we are having 4 categories of colored cube. That is one-sided, two-sided, three-sided, and colorless. 3 we are having colored, and 4th one is colorless. So from where I can check out the one-sided colored cube? From where I can check out one-sided colored cube? From surface, from edges, or from the corners. Okay, my question is, yes Nazir, I am repeating. My question, student, is I just wanted to know one thing from your side, from where I can check out one-sided colored cube. Should I check out on the edges or on the corners, or I have to check in the surface? Because there are only 3 things: the surface, edges, and the corners. So surface are needed, edges are needed, or corners are needed. Which one is needed? One-sided colored cube. Where can I check out from there? In surface, in edges, or in... Yes, correct one, J. All right. Okay, so there is some lag, I think, student, right? Okay. So I can from surface. I will repeat, student. Let me complete this one. Then I will come back to the second part. Okay. I know that one was asking me one question. Just hold on, student. So from one-sided colored cube we can obtain from surface. Now coming to one example. This is, let's say, okay, let's consider this, student. Or instead of this, maybe this will help you. Okay. Let's suppose this is one surface. This is one surface. This is one surface. So in one surface, in x-axis, from this line will show you, from here to here, I will have in generalized way A parts, or you can say A cubes. Okay. But this one which I will receive from this side is not of my use, because this is in H, and here I am having one more surface. So because of two surface, this one will be two-sided colored cube. So this is not of my use. Once again coming to this H, again I am having one cube in this portion, which is of no use for us, because this is in the contact of this side wall, right? So this is again two-sided. So in single axis, we just we need to subtract 2, A minus 2 in x-axis. But in a surface, we are not having x-axis, we are also having y-axis. Like this. Fine, student? So from here to here, total A parts will be there, but this one I am receiving from, which is in contact of this edge, is of no use because this is in the contact of this wall, which is again colored. So it will be two-sided colored cube. So you need to subtract this one. Again, for this one, which is in the contact of this edge, right, which is in the contact of this edge, the cube which is here right now is in contact of this edge. This y is obviously two-sided colored cube, so you have to subtract 2 again. Overall, coming to again in the room where you are sitting, just focus on the wall which is exactly in front of you people. Okay, just look at that wall, student. You can understand, it's very simple. Fine, and you can derive the formula by your own. You don't need to memorize. Fine. Can you see, a student, the wall which is exactly in front of mine is having x-axis and also y-axis, right? So from x-axis, that means from there to here, I am having A parts because generalized way is A, right? But that one, sir, that last one which is in contact of that edge, and this last one which is here is on contact of this edge is of no use. The reason is very simple. Two-sided colored cubes will be there. So what I will do? A minus 2. That's about this x-axis. But I am having one more, like this one, y-axis. So this one and this one is again of no use. So I need to subtract once again. So A minus 2 once again. So A minus 2 multiply by A minus 2. Can I write it like A minus 2 square? This is for a single surface. I know that we are having overall 6 surface. So definitely I need to multiply it. So that's why I am multiplying it by number of surface. Why I am writing number of surface? Why not I am writing 6? There is one reason, student, because most of the time in most of the question you can check out that there is only one color which we are using, but sometime it happens that we are having 2 colors, right? So suppose we are having 2 red surface only and you are checking for the red colored cubes only. So definitely instead of 6 you will write 2 here. So that's the simple formula. Otherwise, coming to this example, can you check out from here? This is one particular surface, the upper one, and the middle portion is only the one-sided colored cube. This one and this one, which I have denoted with the help of arrow, is in contact of the next wall. That's why it's two-sided colored cube. So you need to subtract these two in x-axis. Again in y-axis, if you are checking, you need to subtract these two. So once again A minus 2. So that's why A minus 2 whole square. And for this example, if you will check out the middle one, 1, 2, 3, 4, 5, 6, 7, 8, 9 is that one-sided colored cube because we are having overall 6. So 9 into 6 will give you 54 for your answer for this question. Otherwise, if suppose you are putting the value A for this example, which is right now 5. So 5 minus 2 is 3. 3 square is 9, multiply by 6 will give you 54. Is that clear to everybody or there is any issue? Students, is this clear to you people now? What's happening? The video is stuck or you can listen me, student, because I'm not getting any answer from your side. I don't know. Okay, let's continue. So here is the next point, fourth one. It is two-sided colored cube. Okay, so let's come. Okay. All right, Jay. All right, that's good, student. In case if there is any problem, do write it, okay? If later on even I'm seeing it, I will make you understand the things. So let's come to this point, okay? So before answering the number of two-sided colored cube and before thinking about the formula of the two-sided colored cube, let's check out one thing. From where we can check the two-sided colored cube. What do you think, student? In the surface, in the corners or in the edges? Your answer will definitely be that edges are the portion from where we can count the two-sided colored cube. Okay. So coming to this example, can you see, student, this is one edge. I just have underlined. This is okay. Oh, all right, student. I will explain a minus 2. Let me complete this two-sided. With the help of this, if you can understand this one, you can understand this too. It will be easy for me and you to make you understand and to grab the thing. Okay. So let's check out. This is one edge. In this edge, I am having overall. I am just taking the example. In this edge, I am having 1, 2, 3, 4, 5 parts, or I can say I am having 5 cube just because of this example, right? But out of 5, these two, this one, this corner and this corner one is of no use, because obviously this corner is of in contact of 3 surface 1, 2 and 3. That's why this is 3-sided colored cube. So I don't need to count it. Similarly, if you check out here, this corner one, this is again of no use, is having 3 surface. So this is of no use for me, right? So right now for us, we can see that we are having only 3 cubes which are needed really, which are 2-sided colored cube. The reason you can understand, the rest of 2 are in contact of 2 corners, and that will be always for whatever the value we are having for particular A, whatever the cube is, right? So definitely, yes, very good, Chandranath. So for in generalized way, I am having overall 5 parts. I need to subtract 2 just because 2 are in contact of 2 corners. So the remaining 3 is for my use, right? But these 3 I am receiving from one edge. I am having overall 12 edges. So 3 into 12 will give you the correct answer, that is 36. So this is the answer for this cube. But right now let's generalize it, okay? So instead of thinking the 5 parts, you are no, Arun, how A minus 3, how it can be? Just listen to me, okay? So instead of thinking 5 parts, just listen. I can say that I am having A parts in single edge. This is one edge. Okay, so in one edge I am having A parts. The value of A is depending on our question. It can be 5, 6, 8, whatever it is. But definitely we are having 2 corners in one edge, and these 2 corners are of no use for us. The reason is very simple, because these corners are in contact of 3 walls. So that's why I have to subtract these 2 always, whatever the value of A is, right? So A minus 2 I am receiving for one single edge. I am having overall 12 edges. So definitely I need to multiply it by 12, or in generalized way I am just writing, just multiply it by number of edges. Okay, is that clear? Now coming to this point, why A minus 2? This is one surface. In the surface, overall from here to here, I am having A parts. I am not counting it, the value of A like 4, 3, 5, 6, whatever it is. In generalized, it is A, right? But this one and this one, which I have circled, is not of my use, because this is in contact of this edge. And can you see, student, then that if you are checking about the cube which you are receiving from this end, because this is black, I don't know if it is visible to you, right? So obviously these 2 surfaces are in contact. So how can you count it? So you need to subtract this. So that's why A minus 2 one time. Again I am having this one also, right? This axis also. So right now this and this you need to subtract. So that's why A minus 2 whole square multiplied by number of surface. Yes, Prashant, I will definitely. I always solve all the questions without any formula, and that's what I wanted to make you understand. But what happened is, student, generally, because it is a 3-dimension figure, right? So student don't understand generally don't understand in one go. I need to explain more and more, but you can understand, because if you can check out in the room where you are sitting, you can understand it. Okay. So let's check out one more formula. It's 3-sided colored cube. I will take one example after writing all the formulas, right? Then you can understand. I will make you understand in a simple way. Don't worry, student. I don't want any complex explanation either from my side, and I don't want anything which we can make easy. Why we are converting it in a difficult way, right? We have to convert difficult thing in simple manner. So just give me one answer first of all. Three-sided colored cube, what you are thinking? For three-sided colored cube, should I go in the surface or in the edges or in the corners? So here in this example, this is one corner, right? This is one corner, another is here, third one, fourth one, fifth, sixth, seventh, and eighth one is on the back side, right? So three-sided colored cube, obviously we can check out in the corners. And to understand this, you don't need me, student, or you don't need this example. You can check out from the room where you are sitting. Can you see? Can you please check out? And then in your room, you can check out that there you are having four corners which is in contact of upper wall, right? Four are in the bottom one. So overall we are having 8 corners, and definitely we will have 8 three-sided colored cubes. So that's the value of three-sided colored cubes. That's it. Is that clear to you? Now we are having the last point, the 6th one, that is colorless. Okay. So what do you think, student? Yes. Colorless cube we cannot check out either in the surface or in the edges or in the corners, but you have to imagine, okay? So let's try to understand this thing. Yes, fine. Okay, all right, student. So right now I am in colorless cube. So let's check about. Let's consider this room as a cube, and this middle portion when right now I am standing and where right now you people are sitting, okay? So this middle portion is that part from where we will receive colorless cube from the inside one. Okay, that's fine. Now the point, student, is let's check in x-axis. From there, because we are in the room, we are having this left wall or the right wall, right? So from this left wall to this right wall, I am having overall 5 cube for this example, but in generalized way I am having A parts, and for these A2 parts from this to this one, right? Can you understand this, student? I am talking about these two walls in x-axis. So we are very good, Shashank. So right now I am having total A parts, but for these A parts, the one which is in contact of this wall, you cannot consider this one because this is one-sided. For this one which is in contact of this wall, you cannot consider because it is one-sided. So for these two walls from here to here, you have to subtract these two because these two are in contact of these two walls, right? So in x-axis you will receive A minus 2. First one. The second one, I am having y-axis from here to that back side one, okay? Overall, this one. Can you understand it, student? Check out in the room you are sitting. Don't consider anything else. It's very simple. It's that simple, right? So from here to there, I am having total A in generalized. In generalized way, I am having total A parts. But the cube I am having, which is in contact of this wall, I am receiving, which is in contact of this wall, is obviously one-sided colored cube being in the contact of this portion, right? This one. Once again, the cube I am having, which is in contact of that wall, is of no use. So I have to subtract 2 once again from here to here for this one and for that one. So A minus 2 I am having in x-axis, A minus 2 I am having in y-axis. Now I am having this height too, right? So for starting from the top to this bottom floor in overall like this, I am having A parts, A cubes. But those two is of no use, that one which is in contact of this surface, and that upper one which is in contact of this upper wall. So I need to subtract 2 once again. So I am having A minus 2 in x like this, A minus 2 in y, and A minus 2 in z. So A minus 2, A minus 2, A minus 2, that means, can you write it like this? It is A minus 2 whole cube. So these are the formula all over with the help of which you can solve your question. If you can memorize it, that's really good. That's really good, student. If you cannot memorize it, You don't need to worry. It's that simple that I will make you understand with the help of the value A only, right? So if you want to note down all the formula, you can. Have you noted down all the formula? Let me know if there is any query from your side, if there is anything problematic. Otherwise, now I can start the question, because that's it. That's all about this. Any query, student? Any point which is not clear to you? If there is, then do let me know. Do tell me, sorry. Do tell me so that I can make you understand. Otherwise, I will start. Somebody was asking me, please make me understand point number first and second. Harsha, okay. See this is cuts. Cuts means I am having, let's say, simple straight line, right? So if I am saying that you are going to convert it in 5 parts or in 4 parts. For example, if you are converting in 2 equal parts, you need to cut it once, right? For 3, you need to cut it twice. For 4 equal, you need to cut it thrice. So definitely the number of cuts in one axis is always 1 less than the number of parts I am having. As we are having 3-dimensional figure, so you need to multiply it by 3. Okay. Total number of cubes. In x-axis you are having A parts, in y you are having A, in z you are having A. So A into A into A, or A cube, that's the formula. Okay, so let's take one example one by one. Now I am removing these formulas. Maybe you have noted down all the points, student. Fine, let's take one example. This is already the example I have given you in the beginning. But for you guys, I am just going to change the example, because this, with the help of this diagram, I will teach you. But you are not going to solve this question only. Here is next question for you, okay? You are having a cube of dimension 16 centimeter. You just colored it with red color, and then you divide it into small cube of 4 centimeter. Is that clear? So you are having a cube of dimension 16 centimeter. It is painted by red color, and then you are dividing it into small cubes of dimension 4 centimeter. So do tell me the first point. I will definitely Dinesh, don't worry, with the help of this example I will make you understand. Okay. So my first question is, tell me the total number of cubes you will have after converting it into in the parts of 4 centimeter. So what you will think, a student, is the first point that needed to come in your mind is the number of parts we will have in a single axis. So do tell me one thing. If you are don't think about cube. Never, a student, you don't need to think about cube. And if I will tell you, because I have already given you the formulas, because most of the time a student needed formula. Otherwise, I am not the one which will go with the formula. I will always think in my mind, and I will not think a cube. I will think a straight line only, and I can solve it. Any of the question. I wanted the same thing from your side, because I am your mentor and you are my students. Okay. So let's check out if we can. Okay. So I just thought that I am having a straight line of 16 centimeter. I am going to divide it into small equal parts of 4 centimeter. So definitely there will be 1, 2, 3, 4 parts will be there, and 3 cuts are needed. Otherwise, if you are thinking about the parts which we will have, you can write it like A is parts, and the parts will be always 16 divided by 4. So we will have 4 equal parts for this question, right? So total number of cubes I was thinking about. So I just thought that I am having a 3-dimension figure, and I am having 3 axes, x-axis, y-axis and z-axis. So I don't need to think about all the axes. I will just think about a single axis and then multiply it by 3, and that will be my simple answer. So in a single axis, in a single straight line, this is one axis, let's say. This is one x-axis, let's say, okay. I just thought that I will have 4 cubes, okay. So 4 in x, 4 will be in y, and 4 will be in z. So the direct formula will be 4 to the power 3, and answer will be 64. That's it. It's that simple. Now, the next question is, obviously, we are going with all the questions. I have written all the formula. I am just checking it, okay? You people will tell me the answer. I will explain it by my own. So, next question, student, for you is, total number of cuts required to convert this cube of dimension 16 centimeter into 64 equal parts. Okay. So do write the answer from your side, student. I am checking your answer too. Don't worry. I am explaining for those who are not getting my point yet, but who have understand, just write your answers. Most of the students are correct, but I'm not calling your name, so that's all okay. If anybody is wrong, I will definitely point you that moment, okay? So total number of cuts we are required. Obviously, if I'm thinking about a cube, I will get puzzled. And let's say I am not having formula memorized in my mind. So what I will do, I will just, very good Jay, what I will do, I will think about a straight axis, about a single line. I will not think about the y-axis or the z-axis. So what I am thinking, that I am having a single line, let's say, x-axis only, right? In x-axis, if I am having 4 parts, the number of cuts I required is 3, okay? So I can write it in this another way, that is, if I am having 4 parts, or generally if I am having A parts, the number of cuts is always less than that. That's why A minus 1, because somebody was asking me point 1 and 2, so that's why writing the formula, otherwise I will not write. So in generalized way, there is A parts in single axis. For A parts, you need A minus 1 cut, because I am having a 3D figure, so definitely you need to multiply it by 3. No, Chandranath, are you sure? You have written 6 cut. Please check out. So in x-axis right now, I am having 3 cuts. Because we are having a 3D figure right now, you need to multiply it by 3. Your answer will be 9 cuts. Is that clear? Yes, Devarshi. Very good. Chandranath, please correct your answer, student. Why you are writing Nidha, in fact 27, how it can be? For what you are writing 27? Are you solving the question for colorless cube or what? So that's the first 2 point, okay? Now the next point, that is for the same question, is calculate one-sided colored cubes. Calculate one-sided colored cube. If somebody is having the formula in their mind, they can write it, they can put the value and then convert the question. Otherwise, people like me, if suppose I am not having formula memorized in my mind, I cannot generally, right? So what I will do is, I will just think about one single surface, because I am having the idea. I will not think about this complete cube. Why would I? Because a single surface can make me understand. So what's the need of thinking about the complex thing if it can be easy, right? So for one-sided colored cube, I know that I can check out one-sided colored cube in the surfaces. I know that I am having total 6 surface, but I will not check out all the 6 surface. I will check out only one surface. In the single surface, from here to here, these parallel line is showing me that I am having right now 4 parts. 1, 2, 3, 4 for my question, right? But this one and this one, the sticked one, is of no use for me. The reason we all are having very clear. This is in contact of this edge and which is in contact of another wall. So definitely this will be two-sided colored cube and this will be again two-sided colored cube. So I need to subtract these two, but I am not having this one. For that matter, I wrote A minus 2, because for A, instead of thinking 4, 5 and 6, I just give the generalized one, that's A minus 2, right? Now, right now, I can understand one more thing, that I am having another 2 edges, another 2 axes, right? Y-axis too, not x-axis, then y-axis for a single surface. Right now, I am having 1, 2, 3, 4 parts. But once again, this is the edge which is in contact. So, this is of no use for me and this is of no use for me. So, once again, I received A minus 2 if I am thinking in a generalized way. So that's why A minus 2 whole square multiplied by number of surface was the formula. But I cannot, if I cannot memorize the formula, I am having 4 in x, 2 is of no use. So 2 from here, I am having y-axis, 2 again of no use. So it's overall 4, right? So 4 in a single surface, 4 into 6 will give you 24 as your answer. Is that clear to you people? Very good. Now the third one is, the next one is calculate two-sided colored cube for the same thing, student. Calculate two-sided colored cubes. So two-sided colored cube you cannot check out in the surface, but it is on edges, right? Two-sided colored cube you can check out is always there in edges. Fine. Now the next point, student, is Two-sided colored cube is, if is it in H, I will definitely 64 Vinay. Just wait. Let me complete these points. I will come back to that. Okay. So if you are having formula in your mind, just put the value, solve it. And people like me who cannot memorize the formulas much, right? What they will think? They will think like this. We are having this edge. In this edge, I am having two corners. Two corners will always be there in a single edge. So whatever the value of A is, 4, 5, 6, 7, depending on the dimension of the question, I need to subtract 2 always, A minus 2. Nishant, why will you take z-axis in one-sided colored cube? One-sided colored cube like this. This is a single surface, right? So having this x-axis and y-axis only. So why will I consider z-axis for a one-sided colored cube? One-sided colored cube are always present in the surface, right? And in surface we are having 4 walls. This is x-axis and this is y-axis. We are talking about z-axis because we are having cube. So that's why we have already given the multiplication of number of surface, that's 6. So that has covered the rest of the cubes already. Okay. So right now I was checking this two-sided colored cube. So I was thinking that in generalized way, in a single edge I am having 2 corners. So I need to subtract these 2. Otherwise, if you are generalizing, it is A minus 2 for a single, and then you are multiplying it by number of edges. So right now I am having 4 parts. I'm not going with the formula. I'm just thinking by my own. Okay, how can I convert it? Okay, right? So I'm having 4 parts, but in these 4 parts, this one and this one is of no use because in contact of 2 corners. So only 2 are there, which is of my use. As I'm having total 12 edges, so 12 into 2 will give me 24 as total number of two-sided colored cube. That's so simple. Is that clear? Okay, that's really good. Now, the next point, student, is to calculate three-sided colored cube for this same question. There will be one question most probably in the examination to calculate two-sided or one-sided colored cube, and this dimension is always mentioned there. So instead of writing again and again that this is the cube of dimension this centimeter and then you are coloring and then you are converting, we just fixing the example, student, this one for you people. Okay, this is the example we have fixed already. For any of the question we will solve because that's all about cube, right? So the next point is three-sided colored cube. So for three-sided colored cube, definitely you will think that will not go with the surface, will not go with the edges, but we will count the corners, because everybody can understand that three-sided colored cube we can obtain from corners only, and we are having 8 corners. So three-sided colored cube is definitely 8. That's very good. All of you are correct, student. That's really good. Now here is one last point to understand. Colorless. Although I have explained all the formula with the help of this example 25 centimeter, but I am repeating with this example so that you can relate it actually with the room where you are sitting, student, and you can imagine any time even if you are not memorizing the formula exactly, and you can derive it by your own. Okay, so colorless cube. For colorless cube, generally I told you that I am having overall 6 surface, student, in our cube, and that colorless is from the inside. Portion. Right now I am standing this portion, and right now you people are sitting in your room. That portion, right, that's inside one will give you the colorless, but it's not that we can count it so easily, and to make it simple, definitely so to make it simple, there is definitely one simple point, student. I am having this x-axis, that means The left, Varun, let me complete. Okay, once then I will. So I am having these two walls in x-axis, the left one and the right one. So in this x-axis, which is in contact of left and right, overall I am having A in generally, but I need to subtract 2 because of two walls, right? Because of two surface, because the one which is in contact of these two surface, the left and the right wall, is obviously the one-sided colored cube. So I need to write A minus 2 for x-axis. Similarly, for this one, y-axis, beginning from this wall to that one, which is exactly in opposite of this one, right? So from here to there, I am having total A parts, but the one which is here, I mean, is in contact of this one. So I need to subtract this, and similarly the same thing is there, right? So minus 2 is there. So once again I will have A minus 2. Now for this height I am having two walls in contact, the upper one and the bottom one. So I need to write A minus 2 once again. So A minus 2 in x, A minus 2 in y, and A minus 2 in z. So you will have the formula like A minus 2 multiplied by 3. Otherwise, if suppose I am not thinking like this, so what I will do, I am having 4 parts. The inside one, this layer, inside one is also 4, 1, 2, 3, 4. But this is my wall, and this one is not of my use. So this 2 is only for my use, right? So definitely 2 is in single axis, 2 will be in y, 2 will be in z. Right? Answer is 8. Now clear? Varun, you were asking me some question, but that time I just skipped your comment. So you just can write your, can you please write your question once again, so then I can read it, okay? Because right now I was explaining one question, so I just noticed that you asked me one question, but I was not reading that time, that your query. So that's all about this part. Is that clear to everybody? So here are some next question for you people now. So this one you have already solved. Here is the question, student. This is the question. Can you please read the question? Just read the question. This is the one that you are going to solve now. How it come with the formula? Please repeat 64. How it will come with the formula? Okay. 64 was Vinay. That 64. Just read the question. Rest of the student. Vinay, just focus on the things. See, 64 was the answer of total number of cubes. Total number of cubes, right? So total number of cubes, obviously in x-axis you will have some cube, in y-axis you will have some cube, in z-axis you will have some cube, and you will multiply that one. So in generalized way, I told you that A is the value, A is the parts actually. So A in x, A in y, and A in z. So A multiplied by A multiplied by A is denoting A cube. In that question, the value of A was 4. So 4 cube definitely will give you 64 as the answer. Horizontal and vary for surface. Can't we check for edges? Definitely you will check for edges, Varun. Why not? You will check for edges. You will check for edges when the question is about two-sided colored cube, because I am checking on surface, I am checking on edges, or I am checking in corners. That is totally depending on our question. If the question is to find out, to calculate this one-sided, I am having the first thing in my mind that one-sided colored cube we have to check out in surface only. So that's why moving in surface. In surface I am having x-axis and y-axis. You know that we are having four boundaries for a single surface, for a single wall. You can understand. Even this frame is also giving you the idea, right? To get A minus 2. See, A minus 2A squared to A minus 2 squared. No, Varun, you cannot think it like this, okay? The way you are thinking is again similar point, because I have taken the upper wall like this one. If suppose I am taking this wall which is exactly in right side of mine, so you will think like this. So in any way, the point you are saying and the point I am saying, both are same. It's just that right now I am checking in this way, this wall, okay? If suppose you are checking in this one, so that will be the same. So we may get a minus 2 square if I'm not wrong. Yeah, and any time, in any time. That's what I'm saying, right? So it's just that I am checking. Can you please understand, okay? In the room you are sitting, there is upper wall. There is a upper wall, right? In upper wall, we are checking like this and this, thinking like this, right? I'm having one left wall also. So in left wall, this height one, if you are thinking, you will think like this and this. So everything is same in any situation. Okay? Yes. So student had given me the answer 98, 96. What's the, okay, fine, got. So here's some question. So now for this question, student, let me complete one thing. First of all, I have not given you the dimension, how you are solving the question. The question is having dimension 25 centimeter and you have just colored it with a single color, let's say blue color, and then divided into small cube of dimension 5 centimeter. Okay, so definitely you will find out number of parts first of all. So parts is A, which you can obtain after dividing it. So I am having 5 parts. Now the question is to calculate at least one-sided. Now this one is really important. At least one-sided colored cube. So this at least is something really important, that if I have mentioned at least, definitely there will be some meaning of this at least. Otherwise, I have just wrote earlier one-sided colored cube, two-sided colored cube. What is the meaning of at least? At least indicates minimum. So how can I relate with any example? Yes, I can relate it. The cutoff in the examination, right? You all can understand the meaning of cutoff, right? The cutoff in the examination is always minimum score, right? So that's at least. Above that is also passed, will also be considered as a pass. Let's say if I'm saying for any example, for any exam, let's say I'm saying that 80 marks are the cutoff. Let's say, okay, not talking about your exam. Okay, so 80 is the cutoff, let's say I'm saying, okay. So if 80 is cut off, the one who is having 81, 82, 83 will be considered, but the one who is having 79.5 will not be considered. So at least consider the minimum value. So what you want right now for this question, you want at least the one having one-sided colored. Above that is two-sided, you can also check out that, and above that we are having three-sided. So overall, you need to add one-sided, two-sided, three-sided, you will have the answer. Otherwise, if you check out, if you can check out a student, the total number of cubes are divided into 4 categories of cubes: one-sided, two-sided, three-sided, and colorless. So you are just subtracting the colorless, right? Because for one-sided colored cube, the formula is 5 minus 2 whole square multiplied by 6. Here it is 5 minus 2 multiplied by 12, and it is 8. Okay, so 5 minus 2 is 3, 3 square, 9 into 6, that is 54, it is 36, and then it is 8. Yes, Aman, I'm getting all of your points. So, Shashank was also writing that they have solved the question according to this one. You have solved the question according to 16 centimeter. In any way, if you are understanding these things, you all are correct. Okay, if suppose the question is to calculate at least two-sided colored cube, what you will do? You have to select from here two-sided plus three-sided. If the question is at least three-sided, then you will mark only 8. Fine, that's good. So here is the next question. Please read it. Just take this dimension, student, because options are I have given. Okay, I have given options. If options are not given, then whether you are selecting 16 or whatever. Yeah, that's good, Snehashis. That's what I was explaining, that for the previous question, because we just left colorless, so you just can subtract it from the total number of cubes. So right now we are having the next one. Yes, Arun, all right, student, very good. Can you see, student, the next question? Please read it. It is at most one-sided. So this is important. The underlined point is at most. So what do you think? 54 only. Okay. $98. That's good. Okay, let me explain. At most means maximum. For example, your mother has given you 10,000 rupees, or just saying that you don't need to expend more than 10,000. So 10,000 is the at par situation. You can just go with that money, but not above than that. Okay, so that's the bar on 10,000. But less than that, 8,000, 6,000 is appreciable, but not more than that. Okay. For example, you want to purchase a mobile phone and you are having a budget in your mind that I will purchase of 10,000 at max, but not more than that. So that's the at most condition. So at most we can go with one-sided, but not more than that. But we are having one more thing before that, that is colorless. So you have to add these two. So for colorless, the formula is a minus 2 whole cube. For one-sided, you are having a minus 2 whole square multiplied by number of edges. Okay, so the value of a right now is 5. 5 minus 2 is 3. 3 cube is 27. And the value of a is 5. 5 minus 2 is 3 square. 9 into 12, 9 into 6, sorry, is 54. So the answer, student, 27 plus 54 is equal to 81. Is that clear now? It is at most. Good. Now here's the next situation. Please read it. I know these things are clear to you. That's the last situation, student. Just read the directions given there. And this is the last thing which you needed to learn. Then the topic is over. Okay. Let's read the condition. We have given two opposite sides of a cube are painted with blue color. Other two opposite surfaces are painted with red color. And the remaining two surfaces are painted with green color. Okay, fine. So we are having right now, we are having a cube where we are having a dimension of 25 centimeter. You are converting it into small cube of dimension 5 centimeter. So definitely the value of A, that means the number of parts in single axis is 25 divided by 5. That means 5 parts. Okay, right now the condition is, the question is same, the value of A is same. If you are using the formula, that will remain same. Or if you are thinking like me, like I was trying to explain you in single axis and then converting it into next one, right? So definitely you all will go correctly. But we just need to read the directions carefully. Varun, I will explain almost how can we consider colorless. At most is maximum situation. Yes, Varun. Student, just read the question and try to solve it by your own, okay? See, at most is the maximum condition. That's why I was saying that I am having, let's say I want to purchase a mobile phone and my budget is of 20,000 for example, yet, or 10,000 for example. 10,000 is my budget, that I want to purchase a very good mobile phone of maximum 10,000, not more than that. So 10,000 is my bar. I'll not go above that. But if I'm having something in 5,000 or 2,000, I will obviously consider that. Right, so something less than that is considerable. So if at most one-sided, that's the maximum condition, that you are going to select that cube in which the maximum color should be only in one-sided. So it will include colorless. So that's why. So you all are giving me the example. Let's read the things first of all. Okay, all right, student. Let me explain now, okay. Two opposite of a cube are painted with blue, other two are painted with red, and remaining two are painted with green color. So let's take the example of this room only. It will make you understand things in a clear way, right? So this top and this bottom is red. This left and that right is of which color? We are having three colors, right? Red, green and blue, right? Sorry. So this top and bottom is of red. This left and right is of green color, and let's say this front and very good, Aman, very good. So this front and this back is of blue color, let's say. So we are having two walls in exactly in opposite position or of same color. This time you are going to select the number of one-sided colored cube only. So definitely for one-sided colored cube, cube, you will write, you will either write the formula or you will think in your own way. So we know that the formula for one side is a minus 2 whole square. That's what we obtain in a single surface, and then we multiply it by number of surface. So we know that overall the number of surface are always 6 in any cube, but why I was writing number of surface in generalized way, just because of these category of question, because overall are 6 surface, but the question is if dependent on any particular color, and there are multiple number of colors, so we have to check the number of surface according to that color, right? So right now the value of A is same, that is 5 minus 2 whole square. Now the number of surface, because you are going to check out those cube having blue color only. So this is the front wall which is of blue color, and just opposite of that one is having blue color. So I am having only 2 walls of blue color. So instead of writing 6 for number of surface, you will write 2 only, right? So 5 minus 2 is 3 square is 9 into 2, that's equal to 18. That's it. Is that clear to everybody? Students, is this clear to you people now? So that was all about cube. It's very simple and easy topic. We are not having so many things to understand in this topic, right? We are having less thing. I think I mean to say that we are having only 5 or 6 points were there, right? 6 points were there only. And if you are thinking about at least and at most, so the formula, the thinking will remain same. We have to utilize it again and again. The same thing. This was the concept and the tricks, how you are converting it, the basics, right? So now point a student is, if there is any question coming in examination, because generally there are sometimes one question and sometimes there are not. So this is dicey topic. I cannot say exactly that it will come definitely in your examination, but yes, if it is included in your examination, so definitely I will make you understand, and it's your responsibility to learn the topic in a similar way, in the simple manner, right? So that was all about the things. I hope you have enjoyed the session and learn all the things about cube, right? So students, if you are having any question, any query of this topic, you just can ask me immediately. And if you are having any other question in your mind while you are preparing for examination, if you are having any question, you know that I used to say the same thing at the end of every session, but yes, I will for those who are new, right? So if anybody is having any question of any particular topic, it's not just about cube, dice, it may be any topic of direction or blood relation or anything you are having any problem. So you can just post your question in a very clear manner, because generally what happens, sometimes a student posts the question but that